Jim Sheets here with Smooth On and Buddy Rhodes Concrete Products, and today I'd like to show you how I used our Vitaflex urethane mold rubber in which to make a mold to cast this sleek, shallow, free-form concrete sink. Similar concrete sinks could be done with a process called fabric forming, but I chose to control the process a little bit more with the help of our CNC machine. So let's take a look. The profile was cut using 15-pound tooling board, and this became the model. Texture and tooling marks from the CNC machine need to be filled through an application of an epoxy coating. This rigid coating will also protect the model's surface and eliminate porosity prior to mold making. I chose XTC 3D for its short pot life, 10 minutes, and tack-free in approximately 2 hours. In order to provide sharp edges on the bottom of the model, it is necessary to coat the underside as well as the sides, so the bottom corner will be able to be sanded crisp. I started by using a tape dam to coat the bottom of the model. Dispense A and B components 2:1 by volume into clean containers. Combine both components into a clean mixing container and mix thoroughly, scraping the sides and bottom to be sure to incorporate all the material. Transfer this mixture into another clean mixing container and mix again to ensure a thorough mix. After properly double mixing the material, immediately pour the material and brush or squeegee as evenly as possible. A flexible spreader is a good way to quickly distribute the epoxy evenly. Recoat time is approximately 90 minutes if more than one application is needed to establish a uniform edge thickness. Once the edge is coated uniformly, allow to cure until tack-free. Once tack-free, remove the tape and remove the meniscus by sanding flat. Clean loose debris by vacuuming. In preparation for coating the top side of the model, I elevated the model by placing small plastic cups on the bottom, attached with double-sided tape. I then used painter's tape to defuzz the roller that will spread the coating over the model. I then dispensed XTC 3D to be used to coat the top surface of the model. The goal is to apply the thinnest possible coating while making the surface hard enough to be sanded without losing the original profile. Pour and spread the material with a roller until all surfaces are covered. Allow to cure until tack-free. Once tack-free, you will be able to sand by hand in order to inspect the model for uniformity. After the application of XTC 3D and sanding, I noticed there were tooling marks from the CNC machine that needed to be removed. Ordinarily, this model would be ready with the single application of XTC 3D. But because of the tooling marks, subsequent layers will be necessary to fill the imperfections. I proceeded with a few more applications of XTC 3D, pigmenting the layers with UVO pigments and sanding in between. The different colors provide good contrast, enabling thorough coverage. Since I sanded the final application, I buffed the sanding scratches with polishing compound and wiped clean with denatured alcohol and set aside. Construct a mold box by cutting melamine into the components to allow an area 3/4 inch larger than the model on all sides. I added an additional feature by ripping a bevel on another set of sidewalls, which will help to locate the mold into the mold box. I begin by assembling the beveled sides first. Drill and screw to attach. Using a flush cut trim saw, remove the excess tab from the two long ends. Clean loose debris with compressed air. Using packing tape, cover the open areas of the melamine. This will minimize the chance for the rubber adhering to the melamine. Cover any screws or openings as well. Next, attach the outermost walls of the mold box to the inner walls. These are easily attached with pocket screws. Utilize clamps while attaching the two sets of sides together. Turn the frame right side up and drill a few 1/4-inch vent holes so the rubber will flow into the beveled flange area. Remove any excess material and make sure they are open and clear. Apply sonite wax to all surfaces to aid in releasing during demold. Measure and mark the correct position of the model onto the mold box bottom. Drill through holes from the top side and follow up by countersinking the same hole on the bottom side for a flush screw attachment. Attach the model to the mold box bottom. Using a small amount of Sculptex sulfur-free clay, I fill any uneven edges, making the model watertight to the melamine surface. Tool as necessary to remain as square as possible. Once complete, wipe the surfaces with alcohol to remove any leftover clay particles. Proceed spraying universal mold release onto the model. Brush to distribute and spray again. Repeat this process on the mold box wall assembly. Carefully place the mold box wall assembly over the model, locating its position with melamine spacer blocks and attach with pocket screws. Seal the perimeter bottom with hot melt glue to prevent liquid urethane rubber from leaking out of the box. I chose Vitaflex 40 urethane mold rubber for this project because the mold box will offer dimensional support and the 40 durometer will allow easy demolding of the 4-inch high sidewalls. Begin by pre-mixing part B to be sure no components have settled. Dispense equal parts of A and B, 1:1 ratio by weight or volume. Combine both parts into a clean mixing container and mix well using a variable speed drill with the turbine mixer. Scrape the sides and bottom of the container with a mixing stick to make sure to incorporate all the material. Transfer this mixture into another clean mixing container and mix again to ensure a thorough mix. Begin pouring the mixed rubber into one corner of the mold box. Once the mold rubber has come over the top, continue to pour into itself, keeping the stream behind the lead edge of the flow. Continue to fill the mold box until the appropriate thickness across the back of the mold has been reached. Inspect for possible leaks and allow to cure for 16 hours. Begin the demold by removing the pocket screws and remove the bead of hot melt glue. Using a pry bar, gently break the sides free from the base. Carefully lift the outer walls off of the mold and model. Turn and place the sides upside down and set aside. Carefully lift the edge of the rubber mold up and off the model. Place the mold back into the mold box sidewall assembly to rest. The beveled wall detail provides assurance the mold will stay dimensional throughout its mold life. Make note of the placement orientation of the mold and sidewall assembly so that it does not become misaligned 180 degrees. The master model can be used to make additional molds as needed for production. Simply assemble new mold walls, prep with release agent, and pour Vitaflex again. In preparation for concrete casting, make sure the mold is positioned level on a flat surface. I mixed a generic self-consolidating concrete mix with some old material I wanted to use up. This will be a sacrificial casting. This is a good idea in order to season the mold and helps to remove mold production release agents and waxes that may be present. These will almost always have a negative result on the first castings with discolorations or spotting. Cover and allow to cure overnight. The next day, remove the covering and flip the entire casting over onto foam strips. Carefully lift the sidewall assembly from the mold and set aside. Carefully lift up and off the rubber mold from the casting. Place back into the sidewall cavity. We are now ready to prepare the mold for the first production casting. I wanted to incorporate a slot drain assembly in this sink and did not want it to be integral to the mold, as there may be some variations of the sink over time. I started by building a small mold box from melamine, hot gluing the sides to a base. Using a 1/4 inch acrylic stock, I cut the shape of a slot drain and sanded to ease the edges. Remove the protective paper and apply contact adhesive using the mold box as protection from overspray. Place the acrylic slot model in the center of the mold box and allow to dry. I used MoldStar 16 Fast silicone mold rubber for creating this mold. Dispense equal parts A and B by weight or volume into clean mixing containers. Combine the components and mix thoroughly, scraping the bottom and sides of the container. Continue mixing until well incorporated when there are no color striations present. Pour this mixture into a new clean mixing container and continue mixing to ensure a thorough mix has been achieved. Work deliberately and quickly since the pot life is 6 minutes. Pour the material in a high stream to allow any air bubbles to be released. Fill the mold box until the model is covered by at least a 1/2 inch over the highest point. Allow the rubber to cure for at least 30 minutes. Once cured, remove the sides to release the mold. Remove the acrylic model and prepare to cast the slot plug for the sink. I chose Task 16, a fast-setting urethane rubber. The Task 16 is rigid enough to hold its shape, but still flexible enough to contour to the curvature of the sink mold. This will also be forgiving during demold by not chipping the concrete like a rigid material most surely can. Begin by premixing both components and dispense at a rate of 1 part A to 2 parts B by weight using an accurate gram scale. Combine the components and mix well, scraping the bottom and sides of the container. Work deliberately and quickly since the pot life of this material is also 6 minutes. Pour into a new container for a double mix, ensuring both materials have been well incorporated. Pour from one location until the mold is filled. Since I chose the MoldStar 16 silicone, there is no need for any release agent. This is another reason I like to pair Task 16 with MoldStar 16 when making inserts and plug features for casting concrete. They are fast, and there's no need for release agent when casting the urethane into the silicone. The material is allowed to cure for 90 minutes before demolding. Once cured, the plug can be removed from the mold. Notice some flashing from the meniscus. This is easily removed through sanding by hand or a belt sander. Using a mixing stick as a mask, I sprayed contact adhesive on the bottom edge for attachment to the rubber sink mold. I then measured and located the correct position and attached the plug firmly. Sometimes straight pins can be inserted into the plug to aid with attachment. This may be necessary to ensure it does not become dislodged during concrete casting. Apply sonite wax and remove excess to the interface of the two surfaces so a silicone caulk fillet can be applied and tooled. Thanks to the application of sonite wax, the excess silicone is easily removed once cured. I learned how to make this PVC drain connection plug from a fellow concrete artisan, Cody Carpenter. For information on how to fabricate this part, check out the link in the description. Attach the PVC drain connection point to the urethane plug. Sand the outside to abrade the surface. This will provide better adhesion with the concrete. This is set in place with a press fit. Using tape, I covered the top edge where the mold box and mold are in order to protect concrete from falling into this area, which may deform the mold. Apply Aquacon release agent to the mold with a light spray, being careful to cover evenly. For the concrete casting, I wanted to cast a white concrete which contains additional black flecks, creating a good visual salt and pepper contrast. For this, I used Buddy Rhodes GFRC admixture. I calculated that I would need 30 pounds for the face coat and 100 pounds for the backer coat. My 30-pound face mix consisted of white Portland cement, 30-60 mesh sand and black beauty sand, Buddy Rhodes GFRC admix, titanium white pigment, water reducer 420, chilled water. Start by adding chilled water to a clean mixing vessel and add titanium white pigment to the water. Mix well. To this I added 2 ounces of water reducer 420 and blended well. Add the 30-60 mesh sand and blend well. To this add the Buddy Rhodes GFRC admixture and half of the Portland and blend well. Continue incorporating the remaining Portland, stopping to add more water reducer 420 as needed. I then added the black sand and blended well. I chose to add this at the end so the mix would stay as brilliant white as possible. Cement-rich concrete mixes often experience a condition called falset, which is a premature stiffening of cement within a few minutes of the introduction of water. This condition can be easily adjusted simply by remixing to regain fluidity. So after waiting 10 minutes, I remixed and adjusted with water reducer 420 as needed. Dispense the mix into a suitable hopper gun for spraying. Begin spraying into a corner while moving outwards, being careful to use the air from the hopper gun to remove collected sand in the adjacent corners before continuing. Based on the viscosity of the face mix, I adjusted the air pressure to allow the material to be deposited on the mold surface, but not so much that it breaks the mix apart, resulting in excess sand in the corners. As you see, material appears to drip from the nozzle. This material becomes blended with the sprayed material as I pass over the mold surface. This style allows for some minor voids randomly created on the cast surface, which are easily filled and give more character to the casting, embracing concrete's organic visual texture. Once the entire surface has been sprayed, go back and check for any lighter sprayed values while building a little more over the entire area. The prescribed face coat thickness should be approximately 3/16 of an inch. At this point, I was ready to begin mixing the backer layer. For the backer mix, I used white Portland cement, chilled water, Buddy Rhodes GFRC admix, 30-60 mesh sand, water reducer 420, AR glass fibers. The backer mix was mixed the same as the face coat, mixing until fully blended, and added 3% AR glass fibers to the mix. Before placing the backer coat, I tested the timing with a light finger pressed onto the face coat, making sure no material is removed. This timing will always depend on ambient conditions, but a visual sign is when the wet sheen or shiny appearance has left and the surface appears dull. Begin by placing a thin value, approximately 1/4 inch of material onto the face coat, and with light pressure massage the material onto the surface. Continue applying the material until the entire surface has been covered. It is important to execute this step as diligently and quickly as possible as to not allow the face coat to dry, which may cause delamination between the two layers. Once the first value of backer has been applied, now is a good time to clean the hopper gun thoroughly, since this material will keep the face from drying too fast. Compaction rollers are used to press the material flat, compacting and aligning the fibers, which also removes excess air. Continue adding more backer material in layers while compacting until full prescribed thickness has been achieved. I checked the thickness with a long straight pin set into a disc of Task 16 resin at the prescribed depth of 1 inch. A few checks and I can tell where more material may be needed. Once the proper depth has been met, detail the edges to clean up. Cover with plastic and insulating blankets to cure overnight. The plastic reduces moisture loss, and the blankets help maintain the heat of hydration for early strength gain. Once cured, remove the covering and prepare for demold. Start by removing the tape and grind the sides flush with the mold box. Always use proper dust collection and PPE. Once ground, flip the mold box over onto foam blocks. Lift off the sidewall assembly and remove. Lift up and off the rubber mold from the casting. Place the casting onto a mobile cart for processing. Wet the piece and using a 10:1 dilute solution of muriatic acid, gently scrub the cream from the surface, exposing the sand and fines beneath. Continue this process until the exposure of black sand has been achieved. Diamond sanding blocks may be necessary for the sides. Once processing is complete, insert a screw into the task plug for easy removal, allowing the sink to drain. A mixing stick is used to push the foam from the PVC drain connection. Now is the best time to clean any residual concrete from the mold before storing or resetting for another casting. If properly cared for, the Vitaflex urethane mold can last for potentially hundreds of castings. Using straight Aquacon release agent and a microfiber cloth, apply material to areas where there is concrete present. This will soften the concrete, making removal easier. Be careful not to allow pools or puddles of Aquacon on the mold surface for extended periods of time. As you can see, there are small random voids present, and these need to be filled flush with the surface. These can easily be filled with the Buddy Rhodes bone paste. For this project, I chose to use the natural color, bone white, to complement the white cast piece. Once the casting is dry, I mix bone paste with water to a creamy consistency and apply to all surfaces, applying in a circular hand motion to ensure to fill any voids present. Using a soft plastic spreader, I apply over top to a thin uniform thickness, which helps with proper application to all areas. Working in multiple directions helps to work the bone paste into the voids. The bone paste application is complete and allowed to cure overnight. The next day, using a 120 grit diamond hand pad, I removed the excess bone paste by wet sanding. Diamond-coated Spinflex pads work well for the basin. A few small pinholes remained, so I mixed more bone paste and filled as before. This time I will be dry sanding, so I didn't need to wait overnight. Only the bone paste needed to be dry. Once the material was ready, I used the Buddy Rhodes diamond hand pads. The Buddy Rhodes diamond hand pads work well for flat areas, and they may also be used for the contours by cutting them into thinner sections. This will follow the contours perfectly. Another option would be sanding screens on a soft, flexible backer pad. The processing is now completed. Any loose debris will be removed before sealing. The salt and pepper finish looks great. For this sink, I chose the Buddy Rhodes Classic Sealing System, Buddy Rhodes Penetrating Sealer, and the Satin Sealer. First, we apply the penetrating sealer using a damp microfiber cloth and apply liberally to allow as much penetration into the concrete, keeping it wet for a few minutes. This is allowed to dry. I then apply Buddy Rhodes Satin Sealer to the surface and wipe a thin layer over the entire surface, overlapping to avoid streaking and over-application. A little goes a long way. Keep the coats thin. Allow to dry and follow with at least 3 applications for a bathroom vanity. Please visit our website for more information on the Buddy Rhodes sealing system, including the application guides for each sealer. This project is complete. Let's see it in action.